All right, so the last set of questions on your sheet. Number 12 says, an interference pattern is produced using monochromatic light. Monochromatic means mono, one, chromatic, color. So one color, one wavelength. Monochromatic light from two coherent sources, meaning they're in phase with each other. The separation of the two sources is 0.25 millimeters. So the hardest part in these questions is picking out the D, the lambda, the X, and the L. The separation of the two sources, that's D, is 0.25 millimeters. And the fringe separation is 7.8 millimeters. The fringe separation, the distance between the bright spots, that's X. The interference pattern is observed on a screen that is 3.5 meters away. The screen is 3.5 meters away. That's L. And the question wants to know, calculate the wavelength and the color. So you're going to use lambda over D is equal to X over L. Bring your D up. So lambda is equal to X times D over L. And these have to be changed to meters. So divide both by 1,000 or times 10 to the negative 3. So 0.25 times 10 to the negative 3 meters times 7.8 times 10 to the negative 3 meters. And L is already in meters, 3.5. And you will get a lambda equal to 5.571 times 10 to the negative 7 meters. There's a decimal there. Okay, so that answers the first part of the question that says calculate the wavelength. So this is our wavelength. But then it says what color. And on your question sheet, at the very bottom, at the end of the last question, I don't know what question this was. I said 12, but I have a feeling that it's not 12. Oh yeah, it is 12. Okay. So right there at the bottom, there's a chart. And so you need to find, where does 5.57 fit? Well, it fits between 4.9 and 5.7. So this light should be green. Okay, so the second part of the answer is, this is, whoops, it'd be good if you could see what I was writing. This is green. Okay, next question says, I really am wondering if I have the right numbers. I know I'm doing the right questions, I just don't know if I have the right numbers. Yeah, okay, so number 13 says, an interference pattern is produced when light of wavelength 400 nanometers, or 400, nanometers. A nanometer, from back at the beginning of the course when we did the prefixes, the metric prefixes, nano was, whoops, don't put the decimal there, was times 10 to the negative 9. So I wouldn't put the decimal in, I would just leave it as 400 times 10 to the negative 9. It's not in the right scientific notation, but if you punch it in your calculator that way, your calculator will handle it. If you're going to put the decimal in, it'll become times 10 to the negative 7. So that's our lambda, is incident upon a double slit whose separation is 0.25. Slit separation, 0.25 millimeters, that's D. If the bright spots on the screen appear to be 6.5 millimeters apart, distance between bright spots, that's X. How far away is the screen? You're looking for L. So lambda over D equals X over L. Cross multiply first, so it would be lambda L equals XD, and then divide both sides by lambda. So you'll have L is equal to XD over lambda. X, again, you have to go to meters, so 6.5 to the negative 3. D, 0.25 times 10 to the negative 3. And lambda, 400 to the negative 9. Punch all of this in your calculator, and you should get an L to be 4.0625 meters. Okay? Number 14 says, when light of wavelength 640 nanometers, so lambda equals 640 nanometers, or 640 times 10 to the negative 9 meters again. When light of wavelength 640 nanometers falls on a double slit, the interference pattern is formed on a screen which is 6 meters away. Distance the screen is from the slit is L. The fringes are 4 millimeters apart. The distance between the bright spots, X. And this time it wants to know the separation of the slits. You're solving for D. So lambda over D equals X over L. Cross multiply. And so you will have lambda L equals D times X. Divide both sides by X. So D is going to equal lambda L over X. Lambda, 640 times 10 to the negative 9 meters. L, 6 meters, divided by 4 millimeters, or 4 to the negative 3 meters. And you should get a D of 0.00096 meters, or if you want, 0.96 millimeters. Okay, and the last one, number 15, says a single slit of width, so capital D, of width 8 millimeters is 3 meters from the screen, distance from the screen, L. If the distance between the central max and the first max, our X, is 0.2325 millimeters, what color is it? So first we have to find lambda. So lambda, over capital D equals X over L. Take your D up. So lambda will equal dx over L. So lambda will equal 8 millimeters, 8 times 10 to the negative 3 meters, X, 0.2325 times 10 to the negative 3 meters, divided by 3 meters. And you get a lambda to be 6.2 times 10 to the negative 7 meters. So this is the wavelength, but it asks for the color. So you now need to go back to this chart, and you need to find, where does 6.2 land there? Well, it lands between the 5.9 and the 6.5 times 10 to the negative 7, so it should be orange. And so the last part of this answer is orange. All right, and you are done. Okay, so hopefully all is good.